Welcome to another physics session where today we're delving into the fascinating world of gravitational potential energy. Get ready to understand what it is, how to calculate it, and see its effects in real life.
Hi everyone, I'm Dr. Ellie Energy, and today we'll explore the wonders of gravitational potential energy, a key concept in physics that helps us understand how objects interact with gravitational fields. Let's jump right in. Gravitational potential energy, or GPE, is the energy an object possesses due to its position in a gravitational field. Simply put, it's the energy stored in an object because of its height above the ground. Let's take a closer look at the GPE formula to understand how we calculate this energy. Gravitational potential energy is a fundamental concept in physics that helps us understand how objects interact with the Earth's gravitational field. Here's the formula. GPE stands for gravitational potential energy, measured in joules. This formula is crucial for calculating the energy stored in an object due to its position in a gravitational field. M is the mass of the object, measured in kilograms. The mass is a measure of how much matter is in the object, and it directly affects the gravitational potential energy. G is the acceleration due to gravity, roughly 9.8 meters per second squared on Earth. This value can vary slightly depending on where you are on the planet, but 9.8 is a good average. H is the height above the reference point, measured in meters. The higher the object is, the more gravitational potential energy it has. This height is crucial in determining the total energy. Example: if you lift a 2-kilogram book to a shelf 3 meters high, the gravitational potential energy is calculated as follows. The gravitational potential energy here would be 58.8 joules. Now, let's consider another example. If you lift a 5-kilogram object to a shelf 2 meters high, the gravitational potential energy is calculated similarly. The gravitational potential energy in this case would be 98 joules. Let's look at some real-life examples to give you a clearer picture of gravitational potential energy in action. Gravitational potential energy is the energy an object possesses because of its position in a gravitational field. The higher the object, the more gravitational potential energy it has. This energy can be converted into other forms, such as kinetic energy when the object moves. A rock perched high on a cliff has gravitational potential energy. This is because it is elevated above the ground and gravity is acting on it. The higher the cliff, the more potential energy the rock has. If it falls, the energy converts to kinetic energy as it gains speed. The gravitational potential energy is transformed into the energy of motion, demonstrating the conservation of energy principle. In a hydroelectric power station, water at a height has gravitational potential energy, which is converted to electrical energy as it flows down. The falling water turns turbines, which generate electricity, showcasing how gravitational potential energy can be harnessed for practical use. At the highest point, the roller coaster has maximum gravitational potential energy. This is because it is at its highest elevation and gravity is pulling it downwards. As it descends, this energy changes into kinetic energy to drive it forward. The potential energy is converted into the energy of motion, propelling the roller coaster along the track and providing the thrilling experience of the ride. A pendulum at its highest point has gravitational potential energy. As it swings down, this energy is converted into kinetic energy, causing the pendulum to move back and forth. A bungee jumper at the peak of their jump has maximum gravitational potential energy. As they fall, this energy is converted into kinetic energy, creating the exhilarating free-fall experience. A skier at the top of a slope has gravitational potential energy. As they descend, this energy is transformed into kinetic energy, allowing them to glide down the slope with increasing speed.
Let's explore more context where gravitational potential energy plays a crucial role. Imagine a satellite orbiting Earth. It has gravitational potential energy due to its distance from Earth. Next, think about a diver on a high diving board. They have gravitational potential energy because of their height. Lastly, consider a child on a swing. At the highest point, they have maximum gravitational potential energy. These examples show how gravitational potential energy is present in various scenarios, from technology to everyday activities.
Gravitational potential energy is essential in understanding energy conservation and transfer. It plays a crucial role in various physical phenomena and everyday applications. By delving deeper into GPE, we can uncover the principles that govern the behavior of objects under the influence of gravity. By mastering GPE, you can predict how energy changes from one form to another in different contexts. This knowledge is fundamental in fields like engineering, environmental science, and even sports. Understanding these transformations allows us to design more efficient systems and solve complex problems. Remember, the choices you make in problems, particularly height and mass, directly influence the potential energy calculations. These variables are key in determining the amount of energy stored in an object. By manipulating these factors, you can explore different outcomes and better understand the principles at play. Practicing these concepts with various scenarios will build your skills in physics analysis. Engaging with diverse problems helps solidify your understanding and prepares you for real-world applications. The more you practice, the more intuitive these concepts will become, enhancing your ability to tackle complex physics challenges. Thank you for joining today's exploration of gravitational potential energy. If you have any questions, feel free to ask in the comments. Don't forget to like and subscribe for more exciting physics adventures. Until next time, keep questioning and exploring.
Stay curious, keep exploring.